Good morning, everybody. Welcome to exciting Wednesday morning, Chem 1211 with your host, me, Dr. White. Hi, we got a lot to do, so I better get to it. All right, game plan. First of all, I want to do a couple announcements and show you something in Blackboard, which I now have to open up. Then, by popular request, I will show you how to graph in Excel.
Can we maybe do this like on the paper, like drawing, not
You
necessarily
can if you
Excel?
want. You can.
Okay.
All right. Let me move some stuff out of the way. Now download it later. All right. Thumbs up, people. Everybody see Chem 1211, test one information. Thank you, everybody. All right. And I don't know why the spacing got messed up when I uploaded it. It looked right, but that happens with the announcements. All right. Test number one, you will have from Monday to Thursday next week to take and finish test number one at the Glen Ellen Testing Center at COD. If you've not finished test number one by the end of Thursday, when the test center closes, you will get a 0 score. So make sure you take it. It gives you Monday. I think they open from 11 till 7 on Monday and Tuesday, and 9 to 5 or 9 to 6. You look up their hours on Wednesday and Thursday. They're not open on Friday, which is why I have it till Thursday. All right, you can use your own calculator, which I highly recommend. Bring your own. You need a scientific calculator. Go back and look at the YouTube where I taught how to use it. If not, come to my office hours, and you will need a photo ID when you take the test at the testing center. Test number one will cover chapters 1 through 4, which I've already done. The test number one has 11 pages, and this includes the last page of important information. It has 27 problems. 7 are multiple choice. The others are problems which they're short answers, or you got to do a calculation type problem. And there will be a periodic table that you will use taking test number one, which I'll show you in a second. It's located in the lecture section of Blackboard. Now, when I originally did my syllabus, I thought we'd only be doing 2 tests and a final at the testing center, and I do it a certain way. That was shot down. It was increased to 5 tests plus the final. So I'm going to be changing my syllabus. Instead of doing a review on the Monday of the week I'm giving the test, I will do my review on the Wednesday before the week of the test, which means today and in a little while, I'll do the review for test number one. Now, how do you study for test number one? Do the practice problems. If you can do the practice problems correctly, you will be set for test number one. Now, I think I mentioned it, that I teach by my golden rule of teaching. Ooh, what's that, Dr. White? That is, I don't do to my students what I didn't like done to me when I was a student. Don't do that. And therefore, every question on every test I give, including test number one, I've covered the concept in my lecture and also the practice problems at least twice, usually a lot more than twice, but at least twice. I have covered every concept in the test. I don't have any surprise on there unless you haven't come to the lectures, watched them, or do the practice problems. Then, well, that will be a surprise for you. I hope nobody's in that position. So the best way to study for test number one, I like the special effects. Test number one, I'm ambidextrous. I can do both. Uh-oh, it's totally obnoxious Wednesday. Sorry, but anyways, seriously, test number one, do the practice problems, look at the review, and you'll be set to do well. Also, you got to go take it too. All right. Any questions on test number one?
So it's gonna be on the paper, not on the computer, right?
Correct.
Okay.
You will be given, that's a good question. And Michael, yes, it is on, it says it in the announcement, chapters 1 through 4. Chapters 1, 2, 3, and 4. I've covered them on Wednesday, Monday morning. I'll do test number 4, chapter number 4, problem set. I'll go through that Monday morning. But I've done all the actual lecturing and taught the key facts for everything that will be on test number 1 already. And again, I was just looking at the chat, which I already answered. It will be on paper. You'll go to there, they'll give you the, I don't know how they'll staple it together, but you'll get a periodic table and you'll also get the test. The last page of the test will have important information for this test, that this means the 3 formulas for converting from one temperature to another temperature scale. Now, one thing.
And how much time do we have for the test?
Well,
do you know if I have a longer time?
All right. There's no chapter 1 practice problems, and Anna, I'll get to your question in a second. All right. Chapter 1, the only thing you really have to know about it, and when I go through the review in a little while, I'll talk about that. And if I don't, say, well, you promised, and ask me that question again. Now, as to time, because normally if we were face-to-face, you get 50 minutes. And my tests are designed that if you've done the practice problems correctly, hopefully you all did them correctly, you should be done in about 35, 40 minutes. I don't write tests, so only the best student, which is usually in math and science, me, could finish, and the rest couldn't. That's not fair, and that's why I don't do it. Now, in terms of time, like I said, normally you get 50 minutes, but because of distractions maybe in the test center and all that, people coming in and out and things like that, I will give you an hour and 15 minutes. If you are a special needs student and I've gotten your letter and it says double time, you will get double time. In that case, 2.5 hours. And that's through the Center of Access and Accountability. I want to give it always the wrong name, and I totally support them and everything they stand for to help students who need special help. All right. You're welcome, Michael. And remember, all questions are good questions in my class. Now, before I do the review, I want to do something. I just clicked the wrong button. I have to minimize something. I want to go through how to graph. Now, also, I like to clarify something important because I got an email. Actually, all the faculty teach 1211 net got an email that some student tried to return their voucher for the chem kit because the instructor said you don't need it. That wasn't me. You need to have a chem kit. I've sent out information. It's also in my syllabus where to get the chem kit, and you need it. I didn't mention it yesterday, but for the lab we did yesterday that's due next Tuesday, I'd like you to take this one picture of your cup, one of the cups with a thermometer, and you just plop the Alka-Seltzer in there, and it may be fizzling a little, bubbling, fizzling. Oh, I just made up a new word. Put that in the dictionary, fizzling. A mistake from Dr. White, meaning it bubbles. And take a picture of that and upload it along with your lab report. All right, now your lab report, someone asked, you can either type it, because this you don't have to draw anything, type it out into Word and upload that, or if you can print it out, write your answers in it by hand, and then upload that. You have the ability to open up a PDF file, you can type it in that and upload it. All right, what I like to do right now is show you how to graph in Excel. You can do this on regular paper, and I just uploaded this morning, I forgot to, the Carolina company, they have a PDF how to graph, I won't say anymore. If you already did it, email me the photo. You should be able to still upload stuff the way I have it set up in Blackboard for labs. You can upload more than one thing at one time or different times. It's not one chance and you're done. All right, thumbs up, people. Everybody see temperature? The spreadsheet on your screen. All right. If you do not have Excel and you want to graph it using Excel, COD provides free access to Microsoft 365, which is the, how should I say, smaller version of Microsoft Office. I personally have my own copy of Microsoft Office, as you can see in the upper corner here. Was I use it for my work and other things, and I've been using it for, I'd say, this many decades. Oh, shouldn't have said that. All right, now for the lab we're doing, that's due next week, and you have to graph. You're going to have temperature, and you take the average. The cold one, you take the average of the two temperatures, and you take the average of the two times, and this is an average right here. And you do it for the three different temperatures. I made up some data here just to show you. So I have temperature, time, put the numbers in. You highlight it. And you can go back and look at this video after I post it later today to see how to do this. Click on Insert. Then the easiest way is click on Recommended Charts. Again, click on Insert. This will come up, this menu. Click on Recommended Charts. You want Scatter. And that's the first one. See where this is different ones? Click on Scatter. Click OK. Again, Insert, then Recommended Chart. The Insert chart will show up, and click on Scatter and click on OK. Now, I wrote. Now, over here, we have our graph right here, but here's something I found out. I haven't done graphs in a long time. Organic chemists don't do that many graphs, but click on Change Chart Type, and you'll see different things. And if you click on each line, you'll see different lines you can do. Pick the first one, which I did, hit OK, and you notice you got your line. Now, the other thing, click on plus if you want. And where it says axis titles, you now have the titles. If you click on the title down here, and that would be temperature. And click on the y-axis, and that would be time. And now this whole graph you can copy, and then for your lab, either you can print it out like that and include it in your lab, or let me get to a new, I'm in a Word document now, and I did Control-C copy. I'm old school. I love to do keyboard shortcuts as opposed to using my mouse. And now I did Control-V, and I've now posted that in. Now, one thing I forgot to do, and I'll do this, is this title. You can put down lab graph or whatever you want to call it. And that's how you do it. So let's go through this again. You put in your data, use the averages. Then you highlight it. You go to insert. Then you go to recommended charts. And then you want to scatter. And then you hit on OK. And then once you get this in, you can get to, which I don't see it right now. When you do it, you'll get to where it says change things, click on that, and you can pick on the scatter with this line. And then this plus over here, you click on axis titles, chart title, and grid lines.
What about if I don't have a plus?
You don't have a what?
I don't have a plus next to the chart.
Huh. Well, did you highlight? All right, here's what you did. Watch what yours looks like this, right, Anna?
Yes, I just don't have this.
All right, now put the cursor over the graph and click on it. You see how you see the little circles around the graph?
Yeah.
That's when the plus shows up.
No, I don't have a plus.
Well, I'll tell you what, come to my office hour. You said you worked. Maybe we'll, between now and next month, Tuesday, we'll come up with a time when we can meet on Zoom for a couple of minutes, and I'll go through it. All right, that's how you do graphing. And again, if you have problems, come and see me on Zoom. All right, any questions? Again, you can go back and look at the video to see how I did this. You could even do it in slow motion and see me. I said it's Obnoxious Wednesday. All right, let me close this. One thing, let me show you. Everybody see the periodic table on your screen right now? Thumbs up, people. Uh-oh. Now, do you see the periodic table on your screen? Thank you, Gianna. All right, this is the one you'll get. Now, it probably won't be green when I had a bunch printed up, I had them printed up on green paper. They're going to probably print it out at their site, and it will be on white paper. And notice the names are not there, just the symbols, because you have to learn those. All right. And you can look at this anytime you want. A copy of this as a PDF file is available in the lecture section of Blackboard.
I have a question for this table. So when we have to say this halogens and all of that, some of the names we didn't learn, like CS,
All right,
FR.
here's what you have to, and I'll do this through the review. The first column right here, lithium, sodium, potassium. Those are the alkali metals. Lithium, sodium, not hydrogen, lithium, send the rest down below too, but I didn't ask you to learn it. Second column, the ones I asked you to learn, magnesium, calcium, alkaline earth metals, alkaline earth metals. Going all the way over to the right side, we're right, the column we're underneath the number 7, fluorine, chlorine, bromine, iodine. Those are the halogens. Number 7, fluorine, chlorine, bromine, iodine. Those are the halogens. And finally, the last column all the way on the right, helium, neon, argon, krypton, xenon, and so on. I forgot what RN stands for. But anyways, those are the noble gases. This column under the number 8, those are the noble gases. Now, you can go back to the video, but just in case. You type into Google or your other favorite search engine, families, and here they'll show you, here's the first one. Is there another one that shows better? Let's just try the first hit. You got to go all the way down to find the families right here. And here are the names of them. Alkali metal, alkaline earth metals. Now, the other ones I haven't asked you to learn these, but the halogens and the noble, they say metals, that should be noble gases. Or, no, I didn't know there were noble metals. That's something new. Know the noble gases. Okay? Yep, P table, Michael, it does help a lot, which if you go back to the video, that's the one I showed you. If we go over here, I have it linked or bookmarked right here. This is an outstanding, the ptable.com. All right. And thank you for the smiley picture. All right, thumbs up, people. Everybody see test 1 review, chapter 1 on your, thank you, Anna. All right, this as a Word document and PDF is in the lecture folder of Blackboard. Let's go through it. For chapter 1, you should know the branches of chemistry. By the way, organic is the best, but I'm biased. I'm an organic chemist. And there's inorganic, physical, and analytical. Next, I asked you to learn the chemical symbols and names for the following elements. So you should know, if I write, what's the chemical symbol for lithium? It's Li. If I ask, what's the name of the element with the chemical symbol Cu? You should know that's copper. And you should know for all these And I only asked you to learn, I think, what, 37 or 39. All right, let's move on to chapter 2. And that is key prefixes in the metric system. You should know kilo is 1,000, which is 10 to the third. Milli, like millimeter, is 1,000th, 1,000th, or 10 to the -3. And centi, like in centimeter, is 100th, or 10 to the -2. Now, next I taught you, and we went through this in a problem set, you should know how to convert a number to scientific notation. And here I give you what I talked about, how to do that. And let's do one. By the way, if I have things in red, that means it's really important. Hint. Why don't you write the following? This is an awful looking 5. All right, come on. Write the following in scientific notation. And when you're done, give me a thumbs up. I see thumbs are coming up, so people are getting done. All right, since I want to get through everything today, there were a decimal, it would be here, but there's not. And you move this 1, 2, 3, 4, 5 times to the right of the first non-zero number. And when there's no decimal, you drop the zeros at the end. And it's times 10 to the x, and x is the number of times you moved it. When the number is greater than 10, x is positive. When the number is less than 10, let's try one. You use x, remember 10 to the x, some number. And this number is never less than 1, never 10 or greater. All right, why don't you write this in scientific notation? When you're done, give me a thumbs up. I guess you can do a thumbs down too now in Zoom. Or you can do a smiley face or anything else you're comfortable with. Thank you, Michael. All right, let's do this. Here's a decimal. move it to the right of the first non-zero number. 1, 2, 3. So I moved it 3 times. When there's a decimal and you're converting it to scientific notation, zeros at the end you keep. So this would be 3.410 times 10. How many times do we move it? 3. But this number is less than 1, so that's a -3, and that's how you do it. And you can go back and look at problems set 2 that I went through, and the video is posted. All right. Next, I talked about significant figures and the guidelines for determining significant figures. And here they are, and I'm not going to reread it because we went through this, but you should know how to determine how many significant figures a number has. And how many significant figures does this number have? I'll give you 15 seconds. Go. Go. Give you another bonus couple more seconds. All right, let's do it. All non-zero numbers are significant. So I have these 4 zeros at the end with no decimal point. No decimal point are not. So this would have 4 significant figures. Let's do another one. How many significant figures in that number? All right, let's do it. All non-zero numbers are significant. Ooh, look, a decimal point. A big one now. And zeros after a decimal point are always significant. So it's 1, 2, 3, 4, 5. And that would be 5 significant figures. Remember, zeros between non-zero numbers are significant. Zeros at the beginning of a number are not significant. And next, we talked about rounding off. And if a number, if the first digit to be deleted is 4 or less, drop it and everything that follows it. If the first digit to be deleted is 5 or greater, you drop that and everything that follows it, and the number in front you increase by 1. And we did a lot of practice on this. Now, this all comes together when you do multiplication or division, addition or subtraction. Now, on test number 1, I'm not going to have any addition subtraction. Later on, when we use it, I'll come back and remind you and teach you again how to do operational rules for significant figures for addition subtraction. But for multiplication division, you didn't, it says it even, know how to do this. Remember, the number of significant figures in your answer is the same as the number of significant figures in the measurement that you multiply and divide that has the fewest significant figures. So when you multiply and divide, you look at the numbers involved, and the one that has the lowest significant figures Your answer has to be that. And we went through this. Uh-oh. Looks like the dreaded extra dot virus got me. There we go. All right, now, when we talked about, we moved on to chapter 3. And chapter 3, I talked about matter. Matter, you should know, I think I mentioned you may not need to know the definition, but I changed my mind, is anything that has mass that occupies space. And there are 3 physical states of matter. And you should know there's solid, liquid, and gas. And you should know solid has definite shape and definite volume. Liquid has indefinite shape and definite volume. And finally, gas has indefinite shape and indefinite volume. You should know this. That's why it's in red. It's in red. You should really know this. All right. Next, I talked about substances, and there are 2 types. One, when we talk about a pure substance, is either an element or a compound. Next, I talked about mixtures. And mixtures are where you have 2 compounds combined together, but neither lose their chemical identity. And yesterday, and I don't have it on here, I talked about homogeneous and heterogeneous. Homogeneous, the same throughout the mixture. Like if you mix salt and water together and the salt dissolves, it's the same, or the air you're breathing is homogeneous. And heterogeneous, like an oil vinaigrette dressing, where the oil and the vinegar separate. Or if I put sand into a bottle of water, I won't do it, but if I did, the sand will plop to the bottom, and the top will be essentially water. The bottom will be a little bit of water, but mainly sand. That would be a heterogeneous mixture. And what's an example of an element? Well, sodium, gold, silver, oxygen. What's an example of a compound? Water, H2O, and things like that. Now, I just realized I didn't have here on the review, because I talked about it yesterday, but I'll do it now. Let's look at the following, and I'll do this. How many atoms are in A? A is hydrogen peroxide. This is not water. Notice you have the element and subscript to the right, a number. That means there's 2 hydrogens there, 2 oxygens. 2 plus 2 equals 4, and that's the answer. Now here, B, we have magnesium nitrate, and I have 1 magnesium. But now I have the closed paren, what's ever inside, you multiply the number of atoms inside by the number subscript right to the parentheses, 2. So how many nitrogen? 1 inside times 2 is 2. How many oxygen? 3 inside times 2 is 6. Add them up together. Hopefully I did that correctly. It's 9. So you should know how to count how many atoms in an empirical formula. Oh, let me give you another one. And forget about the plus sign right now. But this is called the hydronium ion. How many atoms are in H3O plus? And I gave you a D also, calcium bicarbonate. So your turn. How many atoms in each of those? Give you another 25 seconds. I just gave you another 10 more seconds. Let's do it. There's hydrogen. How many? 3. How many oxygen? When there's no number, that's the number 1. Add them together, you get 4. Let's go to do D. 1 calcium. Ooh, parentheses. Notice to the right here, subscript, I have 2. So you multiply this by how many inside. 1 hydrogen times 2 is 2. 1 carbon times 2 is 2. Ooh, look. 3 oxygen times 2 is 6. Add them together, and I get 11. And you should know how to do that. All right, next, I talked about physical properties and chemical properties, and you should know an example for each. And I went through that, but a physical property would be, I'm wearing a dark blue shirt. A chemical property would be, water doesn't burn. Now, a physical change, chemical change, physical change is when something changes its physical state, but still retains its chemical identity. Chemical change, when something changes its chemical identity. And here, physical change, well, when water goes from a liquid to a solid, when you freeze water, that's a physical change. When organic chemists were pyromaniacs when we were little, when you light a candle, the wax is burning to form the flame and the wick, and that's a chemical change. When you digest your food in your stomach, it undergoes a chemical change. All right, next, I showed you the conversion scales, and you should know how to use these. We did that yesterday. Remember, in each one of these, 273 in the first one, 1.832 in the second one, 1.8 and 32 in the number 1. They're all exact numbers. They don't play a role in the determination of significant figures of your final answer. The only thing in these 3 formulas is what you put in there, the measurement you start with. Next, and finally, chapter 4. Chapter 4, we talked about the atom, yay, and that's the smallest particle of an element that retains the characteristics of that element. I guess I should have put all the characteristics, but now the really good stuff. When we talk about subatomic particles, you should know there are 3 particles that make up an atom. They are the electrons, protons, neutrons. You should know that electrons have a negative charge, protons have a positive charge, and neutrons have no charge. Again, the 3 subatomic particles that make up a atom, like the atoms that make up the water I just had, they're made up of electrons with a negative charge, protons positive charge, neutrons, no charge. How do we find this out? You should know Thomson's cathode ray tube experiments showed electrons have a negative charge. You should know the nucleus of the atom is the center of the atom. And you should know Rutherford's gold foil experiments helped clarify or elucidate, ooh, those are fancy words, meaning figured out, that the nucleus contains only protons and neutrons, and the electrons are on the outside in the electron cloud. We talked about atomic number, and the atomic number is the number of protons in its nucleus. Since all atoms have a net zero charge, the following is true. The atomic number, and this you should really know, is equal to the number of protons, which is equal to the number of electrons. Again, atomic number is equal to the number of protons equal to the number of electrons. And the atomic number, everybody see the periodic table on your screen? Thumbs up, people. Thank you, Jasmine, and everybody else who just jumped in. If you look at the upper right-hand corner of each square for each element, hydrogen 1, atomic number, 1 electron, 1 proton. Carbon, atomic number, carbon you should know is C, and that's got 6 for atomic number. That tells you it's got 6 electrons and 6 protons, and so on. Next, I talked about, and I already showed you, you should know the key groups or families of the periodic table: alkali metals, alkaline earth metals, halogens, and noble gases. And you should finally know what is a metal. That's an element that has the characteristics of luster, thermal conductivity, electrical conductivity, and malleability. And examples here are a few: aluminum, copper, iron, silver, gold, lead, tin, and zinc. Those are all metals. And that's my review. Hold on. What you just saw is available to you in Blackboard in the lecture folder, secretly named test number 1 review. Any questions? I guess not. Don't forget, next week, Monday through Thursday, you need to go to the testing center at Glen Ellen and take test number 1. You'll need a calculator. They can give you one, but I'd bring my own, like this one. This is inexpensive and just really the best one out for our needs in this class. You can use a fancier one too, but make sure you practice. Next, you'll need a photo ID you have to show at the front desk, and I'd bring your own pencils. And that's it. Any questions? Oh my goodness, time flies when you're having fun with chemistry and reviews. It's time for a 5-minute break. I'm going to take a 5-minute break. I'm going to get up and stretch, and I'll see you in 5 minutes. Time to get going. All right, I forgot to ask, so I should do now. And let me change the view. Give me a thumbs up if you'd like me to do a review. First of all, give me a thumbs up if the review was helpful to you. Ooh, I even got someone clapping. Thank you. How many of you would like me to do it again for test number 2? Wow. Guess what? It's in the syllabus, I will. Oh, that's another thing I forgot to mention. Let me get back to speaker view. And that is, I'll be modifying my syllabus. When we originally started, right before when I wrote the syllabus, I thought we'd have our tests most of the time online on Thursdays. And you'd have till Friday. And that's why I put reviews on Monday. Because things have changed, you'll take a test Monday through Thursday instead of waiting until Monday, the week you're going to take the test. I'll be changing my syllabus, just moving on the chart for the different chapters, tentative schedule. I'll put the review on the Wednesday before the week, like I did today. All right, let's get on to material that will be on first of all, I better open up the chapter. All right, on yesterday, I talked about where are the electrons in an atom. And they're in the electron shells, and each electron shell has subshells. I also talked about orbitals. Now, yesterday I talked about the electron shells. In this table, you will be given, this is for test number 2 now, you'll be given this an important information. In the past, students had to memorize this, but I won't give you this. And when it comes to shells, the first shell is called shell 1, second shell 2, third shell 3, then 4. Now, the number of subshells in a shell is really hard to figure out. Shell 1 has 1 subshell. Shell 2 has 2 subshells, 3 has 3 subshells, and shell 4 has 4. Now, one thing I will not put on the test, all right, hang in there, I have a technical problem. Here we go. For some reason, my pen didn't want to activate. Now we're in business. I got so many things running on this machine, even though it's a powerful PC, it sometimes burps on me like it just did. All right, remember, oops, wrong chart. Right chart. When it comes to energy, how much energy electrons in a shell have, shell 1 is the lowest. Shell 4 is the highest. And as you go down the chart from 1 to 4, the energy increases, where 1 is less energy than 2, 2 is less energy than 3, 3 is less energy than 4, and 4 is the highest on this table. Now, we talked about orbital designation, which is also the subshells. And here they're given in letters S, P, D, and F. And this is the lowest energy. And this is the highest energy subshell. And this was figured out by lab experiments. And here's another way of writing this. Yesterday I asked, and everybody said they understand what less than means. And I will never ask on a test, but if you have a dying interest where those letters came from, they stand for sharp, principal, diffuse, and fundamental. And that comes from atomic emission spectra studies. Now, once again, this table, you should understand, it will be given in test 2 important information. And orbital S has, you can put the maximum of 2 electrons. And you can also call it subshell S. Orbital P, 6 electrons maximum. And this should really be max number of electrons. Orbital D or subshell D, 10, and F, 14. And when it comes to energy, S is the lowest, F is the highest. And as you go down the chart, top is lowest. As you go down, the energy is subshell has electrons increases. Now, there's certain rules when it comes to where are the electrons. And this slide is going to be very confusing until I explain how to use it in a little while. Orbitals can only contain up to 2 electrons, and the subshells contain more. So actually, this is misnamed. Oops. This really should be subshells. See, even Dr. White makes mistakes. Bad Dr. White. All right, now, electrons, turns out they spin both clockwise and counterclockwise. And the electron spin is represented by an arrow up and down. So where does this all lead us? Well, first of all, the orbitals have different shapes. Switch is totally off for the next 2 slides. S orbital is spherical. Now, an orbital tells you if you could stop all motion, including electrons moving. Boy, would you be powerful. The orbital is the area where you'd find an electron in the s orbital. In the p orbital, looks sort of like an hourglass, top and bottom, and it's 3-dimensional, not just flat 2 on a paper. And that's where you'd find an electron. If you could stop all motion, say, stop. Did you stop? Did your electron stop? No, but I guess I'm not all powerful, but if I could, that's where you'd find a p orbital. And there's ones for D and F I didn't show you. Now, let's talk about, again, this is one of those slides. I'm going to throw some information at you, throw it at you, and then I'll explain how to use this in a little while. Now, when we're talking about where are the electrons, electron subshells are filled in order of increasing energy. The lowest energy is filled first. This is called the Aufbau principle. Aufbau meaning building or build up from German. And a lot of this was done by German chemists before World War II, early 1900s. In fact, a lot of them were Jewish, and because of the Nazis, they left Germany to come to England and the United States. Among those was Albert Einstein. And electrons can occupy orbitals of a subshell such that each orbital acquires one electron before any other orbital acquires a second. And this is called, I don't have it on there, the bus seat rule. Bus seat rule? Think about if you get onto a bus and you know nobody on that bus. What are you going to do? You're going to look for an empty seat. I would, and most people would. And then if there's an empty seat, you'd sit down there. Now, if every seat had one person in it, then you'd find and sit next to someone and fill up that seat if it could take two people, which every bus I've ever been on is like that. Now, no more than two electrons can exist in an orbital, and they must have opposite spins. And this is called the Pauli exclusion principle discovered by Linus Pauling. And I'll explain what this all means. Now, what does this all mean? Well, I better get explaining. There are two ways you can show where are the electrons. Think of it like an accounting for electrons. By the way, my mother and sister were both accountants. Quick story, yeah. When I started doing my own checking account, my mother would look at it, are you doing it right? And she would sometimes spend on hers and my father's a half hour looking for one penny she was off. And I just, one penny, that's not worth a half of an hour of my time. And she'd get mad at me when I would do that, because she was an accountant. Well, what I'm going to be showing you now, there are two ways of accounting for where are the electrons. Isn't that neat how you infused the word, brought it in, accounting, where the electrons are? And it is. And it's very important to know where the electrons are to understand that. Now, one way of knowing where the electrons are is called an electron configuration. And it's time for Dr. White to be subtle. Everybody get the subtle message? Hint, know this. All right, so what is the electron configuration? It's a statement of how many electrons an atom has in each of its subshells. And hint, ooh, it's in purple. That's not really purple, whatever color. My sisters always yell at me, you don't know your colors. I know red, green, and blue. But anyways, those are numbers and letters only. See board for examples. I better get to work. But first, let's try something out I've never done before. So hang on to your whatever. Ooh, it worked. Great moments in teaching chemistry. Not really. Surprised I didn't think of this before. All right, everybody see on my whiteboard electron shells and the subshells? Thank you, Alexis. All right, let's get to work. It was said, see board. If we're in a classroom, you'd be watching me write this. And I would say draw the electron configuration 4, and I'd have a couple of them, and maybe really 3 to 4 points, maybe, or 4 to 5 matters in my mood when I write the test. I haven't written it yet. I write a new one every semester, but they're similar but different. So how do we do hydrogen? Because I want my points. So I want to get a good grade in this class. And if you do that, I'll get what I want. You've learned this. Well, first of all, how many electrons does hydrogen have? Ooh, good question. Well, go to your periodic table. Hydrogen, chemical symbol 1. Atomic number, upper right-hand corner, 1. That tells you how many protons, and it tells you how many electrons. So hydrogen has 1 electron. And I'll write it down here to remind me. So what do? Well, we go to the first lowest energy shell, and that's 1. But you want the subshells are where the electrons are. So how many subshells does shell 1 have? 1. And what's that shell? Subshell, the lowest one? Energy, S. So it's really 1s. Now, this is important. A subshell name is a number and a letter, not just the letter S. For hydrogen, the first subshell is 1s. Now, how many electrons can we put in subshell S, any S, like 1s? And here in this table, which you will be given, you don't have to memorize it, 2 electrons. So how many do I have? Well, I only have 1. So how do I show that? So, like that. You have the number 1, the letter S, and then the superscript, that means above, to the right of the letter, tells you how many electrons. And we're done. And that's how you do it. Oh, let's do another one. And the same question. That looks like a W. How many are draw the electron configuration for carbon? Well, how do you do that? Well, how many electrons does carbon have? I don't know. Actually, I do, but you don't know. So you have to go to your friendly neighborhood periodic table. Oh, I stole that from Spider-Man. And here's your friendly neighborhood periodic table. Carbon, chemical symbol, C. How many electrons? Atomic number tells you the number of electrons and the number of protons. And it's right there, and you see 6. So we now know carbon has 6 electrons. Now, one of the things I've found in taking tests. And by the way, by the time I finished and got my PhD, I took more tests than I want to remember. And some of them were real hard. Do I have time? Yeah. Time for Dr. White's story. In grad school in chemistry at Michigan State, when you're getting your PhD, after you passed a round of tests your first year called the qualifiers, the beginning of your second year getting your PhD, you started taking tests called the CUMs, or cumulative exams. And you took it for the area you were specializing in, organic for me. It was given 3 times a year, each semester. We had quarters, each quarter, and the test could be on anything in organic chemistry. And by the end of your 4th year, you have to pass 4 CUMs, or you're asked to leave and get a master's. The same thing at the end of your 2nd year, you have to pass at least 1 CUM, or you were asked to leave and get a master's degree. Well, the CUMs were beyond tough. I mean, they were really, really bad. My 4th CUM that I passed and I was done with was the beginning of my 4th year. And usually about an organic, we had about 35, 40 organic students taking it. I got the 2nd highest grade. That CUM, that was my last one. There were 2 grades, pass, fail. Thank you, Alexis. I felt good too. When I passed it, we had a big party in my apartment, really big. But anyways, the highest score was 53 out of 100 points. I got 52 out of 100 points. That was passing. 50 and above was passing. I still remember the next highest score after us was only 25. Yep, they were really killer tests. But one of the things I learned that helped me was let the paper do the thinking. So we're trying to draw the electron configuration for carbon. And that's why I wrote down here 6 electrons. Now, you start filling the shell and subshell with the lowest energy. What's the lowest energy shell? That's 1. It has 1 subshell. That's S. What's the maximum number of electrons you can put in S? 2. So how do I show that? The number 1, the subshell letter, S, and I can only put in 2. Now, how many subshells does shell 1 have? 1. How many electrons can I put in there? 2. Uh-oh, I filled it up. So what do? I have to go to the next lowest energy shell. Remember, it goes from top to bottom, lowest to highest, and that would be shell 2. Shell 2 has 2 subshells, and they are S and P. You start from the lowest, then go down the chart. And therefore, I now go to shell 2. The first subshell is S. What's the maximum number of electrons I can put in any S subshell? And the answer is 2. Remember, I'm giving you this table. In the past, students would have to memorize this. So I can only put in 2 electrons in any S subshell. So there we are. Am I done? No, I have 2 plus 2 is 4. I've got to fill up 6. How many electrons can we put in a 2 subshell 2? Shell 2 has 2 subshells. The first one is 2s. Remember, subshell name, number, letter. Subshell, number, letter. Well, if shell 2 has 2 subshells and I filled up 2s, what's the next subshell? 2p. How many electrons can I put max in 2p, 6. So, but how many do I have left to go? Well, let's see. First of all, now I go to 2p, and I have 4. Remember, 2 plus 2 equal 4. So 6 minus 4 equals 2 electrons left to go. I can put max 6, but I only need to put 2. So the electron configuration for carbon is 1s2, 2s2, 2p2. Ooh, let's take a deep breath.
Can you just put like P6?
Can I do what?
Can you do like P6 instead of
No, you always fill the lower shells and subshells first with electrons. Let me ask you this, Anna. Do you have a dresser in your bedroom at home?
Do I have what? I'm sorry.
A dresser, a thing
Yeah.
with drawers.
Yeah.
Does it have more than one on top of each other?
No.
What?
You mean the shelves or?
Yeah, well, here. All right, everybody, don't laugh too hard and hurt yourself. Put knobs on there. You have a dresser, something like that with 3 or 4 drawers?
Yeah.
All right. Now, if you're lazy, like organic chemists are, what are you gonna, if you have a bunch of stuff and it's empty, which one are you gonna fill up first? The top one, right? It's the easiest one to get to. And when that's filled up, you'll go to the next one. Now, in real life, you have things separated, but just for today's argument. Then when the second one is filled up, you'll go to the harder one to get to, the third one down. Finally, when that's filled up, you'll probably go to the one at the bottom and fill that up. Well, electrons are the same way. Instead of drawers, we have shells. You always fill the lowest energy shell first, and you fill the lowest energy subshell in that shell. So that's why you just can't throw them all into P, because they'd be in a higher energy, and that would not be as stable, which in real life, it doesn't happen. Now, it turns out chemists, and this is physical chemists, do this, analytical chemists, and inorganic, I'm not sure about, but have determined where are the electrons. This was theory, but it was then proved in the lab. So this is how Mother Nature throws electrons into an atom. All right, does that help, Anna?
I mean, a little bit, but I'm still confused. Why like
Well,
different?
this is confusing the first time.
Yeah.
So let me go through what I just did again. Instant replay, and it's not even summer for summer rerun. Awful Humor Wednesday. All right, so we figured out by the atomic number, carbon has 6 electrons. For the electron configuration, you put the first electrons in the lowest energy shell, 1. In the lowest energy subshell, that shell first. Well, shell 1 only has 1 subshell. And from the subshell, and I should change this also to subshell, you have S is the lowest. Now remember, a subshell is a number and a letter, so that's 1s. How many electrons can we put in 1s? 2. So I'm going to do that. Next, I look, how many subshells in shell 1? 1s, which you can put 2 electrons. Well, I filled it up. So now I have to go to shell 2, like going to the next dresser. And dresser drawer, and that's shell 2. Again, this table, the next lowest energy after 1 is 2. 2 has 2 subshells. And you start with the lowest energy, 2s. How many electrons maximum can you put in 2s? 2. Well, I've done that, but I still have 2 more to go. And this next subshell in 2 is 2p. You start with the lowest 2s, then you go to 2p. And I have 2 electrons, and that's how you do it. All right, let's do one more. And let's do sodium. Now, first you need to know how many electrons are we dealing with. Everybody see the period, your friendly neighborhood periodic table on the screen? Thank you, Jasmine. I'm going to give you 10 seconds to figure out how many electrons sodium has, then I'll tell you. Time's up. Put down your pencil. No. Anyways, sodium, chemical symbol Na. It's an alkali metal, so it's over in this first column. The atomic number is 11. Remember, the atomic number tells you how many protons, how many electrons. Therefore, sodium has 11 electrons. Well, let me go back to my paper. And I have sodium has 11 electrons. And I abbreviate electrons by the letter E. So what do? We go to the first shell, shell 1. How many subshells does it have? 1. And that subshell is 1s. How many electrons can we put in 1s? 2. So I'm going to do that. Now, how many subshells does shell 1 have? 1. And that's 1s. How many electrons can I put in there? 2. It's full. So I can't put any more electrons. There are no more subshells. So now I have to go to the next lowest energy shell, which if 1 is filled, I go down to the next lowest energy. That's 2. And 2 has 2 subshells, 2s and 2p. Remember, 2s, NES subshell, I can put in 2 electrons. So I will. That's full because I can only put 2 electrons in an S subshell, and 2s has 2. And I have more electrons to go. So I'm going to go to 2p. How many electrons the max can I put in 2p? Well, the table tells me 6. Remember, in the past, students would have to memorize this, but now I'm giving it to you, important information, test number 2. So I now go to 2p, and I say, well, I can put 6 in there. 2 plus 2 is 4. That's only 4. I got to go to 11, so I can put 6 in there. And now I have 10. 2 plus 2 plus 6, 4 plus 6, 10. But I have to go to 11. What do? Well, shell 2 has 2 subshells, S and P, and I fill them up. So now I have to go to the next lowest energy shell, which is 3. 3 has 3 subshells, and they are S, P, and D. The lowest subshell is 3s. How many electrons can I put in 3s? NES subshell, That's 2. Well, guess what? I don't need 2 because I have 11 electrons I need to fill in here. I have 2 plus 2 plus 6, 10 already. So that leaves me 1 left, and I'll put it there, and I'm done. The electron configuration for sodium is 1s2, 2s2, 2p6, 3s1. And that's how you do it. But let's go through it again. First, the tea break. And here we have sodium. We find out from the periodic table how many electrons, 11. We say, all right, what's the lowest shell? And that's 1. How many subshells? 1. What's the lowest subshell? Or on this table, S, we name a subshell with a number and a letter. So that would be 1s. How many electrons maximum can we put in 1s? Well, any s orbital, 2. So I've now put that in there. Next, I look and I say, well, I filled up 1s with the 2 electrons. How many subshells does shell 1 have? 1. Well, I filled it up, so I have to go to the next shell, lowest energy. As you go down the table, this is lowest, then this, then 3, then 4. So I'm now at shell 2. It has 2 subshells. The lowest energy is 2s, which I can put 2 electrons in, and I did. Then I still have a lot more to go. Shell 2 has 2 subshells, and the second one, first one is 2s, second one is 2p. How many electrons can I put in any p orbital? I mean, a subshell, 6. Well, I do that. So 2 plus 2 is 4, plus 6 is 10. I still have 1 more to go. And if you look at shell 2, it has 2 subshells. Those are S and P. Well, I filled it up. So shell 2 is full. Now I have to go to the next lowest energy, which is 3. 3 has 3 subshells, shell 3, and the lowest energy subshell in 3 is 3s, which I could put a maximum of 2, but I'll put 1 because I only need 1, and that's how we do it. All right, everybody take a deep breath, let it out, take a deep breath, let it out, relax. First time I did this, what's going on? And finally started clicking how to do this. Go back, look at today's video. It will help. Now, if you look at online or if you bought the book, you'll find when you get farther down the periodic table, a lot of these rules break down. So what do? Well, you could spend a lot of time learning all the exceptions. It's not worth it. You're not going to be becoming chemists, and even I don't use those. I'll be teaching you something more important. So to maximize the best benefit of our time this semester, it's time for a special gift from me, Dr. White. Shh, don't tell anybody I'm doing this, but for my tests, and especially test 2 and the test 5, I will only, everybody see your friendly neighborhood periodic table on the screen? Thank you, Jasmine. I will only ask you to learn how to do electron configuration up to magnesium 12. And that's my gift to you. And it's really a good gift. And that will, how should I put this politely, eliminate a lot of grief in your life. Yay, Jasmine. don't tell anybody, remember, shh, it's a secret, but I'll only ask you to learn how to go up to 12. Thank you, Michael. All right, if I look at the clock, we don't have too much time left. And instead of starting the electron orbital diagram, I'm going to just say a few words and then I'll let you go a whole 2 minutes early. Wow. Actually, I don't even have to be doing this and just meet with you 2 hours a week. That's all I'd have to, and that's not fair to you. All right. Remember, yesterday the lab from last week was due. If you haven't handed it in, uploaded it to Blackboard, hand in that lab. Labs are easy points. And I'll stick around for a second or afterward if you have a private question that you don't want to ask now. All right, next week from Monday through Thursday, you need to go to the Glen Ellen Testing Center at COD. It's not far from the library. Well, it's not that close either. It's not far from, what's the place that sells coffee? I can't think of their name right now. Well, anyways, I'm not a coffee drinker. Starbucks, thank you. I think decades ago, I was in a Starbucks once. I'm a tea drinker and I make my own. But anyways, you'll need to go there, bring a calculator, scientific calculator, and you'll need to take it. Now, underneath your name, where you print and sign your name, it will say, please use proper significant figures for all calculated answers. So do that, because if it's like a 5-point question and you get it right, but you put too many numbers, significant figures, you didn't round it off, I will take off 1 point. And if there are a couple of on, you could lose some serious points by not following that. So on test number 1, also say on 2, 3, 4, 5, it'll say, please use proper significant figures for all calculated answers. And with that, don't forget the lab we did yesterday is due next week. So start working on that. And remember always, if you have any questions, email me or come to my office hour tonight at 5. I'm thinking, and you let me know, there's a better time frame on either Monday or Wednesday afternoon or evening. Oh, I'll explain, Michael, in a second. That's a good question. Oh, excuse me, a good question. I lost my train of thought. But anyway, for office hours, a better time, if you're working then, and better time, let me know and I'll change it if enough people want me to change it. All right, now, I guess we will go right up to the end. Michael asked, how long will it take me to grade labs and everything? Well, Monday through Thursday, Wednesday, I am tied up teaching, literally. Well, no, not literally, but I'm busy teaching. On labs, I always get it graded before the next lab. So if you handed in a lab yesterday, before next Tuesday, I will grade and post that score in Blackboard, which means probably over the weekend, Friday, Saturday, or Sunday. Friday's not really weekend, but in my mind it is. I'll do that. Now, for the tests, I will pick them up Saturday morning, and by Sunday evening, I will have them graded. I will have your test score in Blackboard. I will send out individual emails, how many points you got for each question you answered on a test. And the Monday after the week I give a test, I will go through the whole test with all the right answers. However, I will cut that out of the videotape. So come to class. If you can't come to class for that Monday, come to my office hours and I'll go through any problem on the test. And with that, well, I'm overtime. All right. First of all, Michael, if you've done the problem sets and can do them correctly, you shouldn't be nervous taking my test. Second of all, if you were there when I gave how to eliminate test anxiety by bringing back a real good memory, I won't go into it now, that will help you. And with that, I'm done. So with that, I'll see you next Monday. Well, even though you're taking the test next week, we'll still have our regular Zoom meetings on Monday, Tuesday, and Wednesday. With that, I'll say, gang gesund. Goodbye.